The webinar will start in just a few moments. The title of our presentation is Revealed Part 2, Understanding the Full Benefits of Switching to Alternative Non-Crystalline Silica Casting Media, ROI Calculations. We will demonstrate the economic benefits of using ceramic casting media. Hello, my name is Brian Davidson, together with Ray Jansen, our Industrial Sales Manager. Ray has been with CARBO for 2 years and has been involved with metal casting for over 10 years. This webinar is being recorded, so if you have a problem seeing it or hearing it, you can always view it later, or if you have to step out to answer your telephone. We ask that you submit some questions through our web portal as the webinar is in progress, and we'll answer those at the end of the presentation. So now I'd like to turn it over to Ray.
Thank you, Brian. Good afternoon, everyone. As you mentioned, in this part 2 of the Revealed series, we're going to be discussing ROI calculations and material properties of ceramic media compared to silica. You know, if you attended the last one, we talked about different advantages that our different people have switched to ceramic media have seen in their foundry. I want to go over a quick agenda of what we're going to cover because we have a lot of data to go over in this one. First of all, we're going to review the material properties, as I said, comparing silica to AccuCast material. Then we're going to go through the AFS economic study, which is basically a study looking at the expenses of staying with silica and what that means to meet the current OSHA Pell requirements. Last, we're going to go through the ROI calculations looking at different foundries types. In part 1, I went over, the AccuCast line of products. These are our 3 main product lines, the LD, ID, and HT. If you want to hear more about them, please review part 1. I'm going to go through material properties on these now. Wanted to start by going over the thermal expansion curve. So if you look at the silica thermal expansion, it goes through an alpha to beta, somewhere between 400 and 600 degrees. That's where you see this rapid rapid volumetric expansion. What that does is it causes problems like veining and other defects that you have to cope with or overcome through other material properties and that in the system itself. So that's like your mold wash and your other things are used to overcome this rapid thermal expansion in a lot of ways. So you start looking at the other materials. So chromite is a very well used material and everything. It's the next highest thermal expansion material. While it's higher than the rest of these materials, it's got still a linear thermal expansion, which means that it's very predictable and has fewer problems than silica when it comes to causing defects and other issues. Then next up is our LD and our ID products. They have under to chromite, so again, you'd expect them to behave very well in the casting process, as they do. Then we have our AccuCast Max series. Again, I didn't show a lot of property data or discuss them in previous slides and everything, because these are very specialized materials we make for very specialized industries. And, so we have them available if need be, but they're not in everyday foundries typically. Lastly, I wanted to show our HT and zircon sand. Zircon sand is considered to be probably the benchmark for maybe the best material to use in a casting process because it has such a low thermal expansion. And the HT material, when we created it last year, we were very pleased to see that the thermal expansion curve lies right on top of it. So it's basically, ideal material for casting process is what we see. Next, I have all this raw data down here, and this is, a lot of it is thermal data that can be used in modeling software and stuff like that. And, I'm going to leave it here for you guys to look at as your leisure later. I do want to talk about the loose bulk density because it's important to understand, how it works with some of these other materials. So like chromite, sand, and zircon have the highest densities, whereas silica's got 100 on the scale, and our LD and ID products come in at 94 and 115, and our HT actually comes in at 107, which is very nice. I want to compare the ID to the chromite material because, as we stated before, our ID material is actually a very good chromite replacement, and that's because of its chilling effect that it has. It's much like a chromite material. One of the big benefits with this lower density, though, is that you use the material on a volumetric basis, even though you talk about density. So you're using it on a cubic foot basis. The ID material having a much substantially less density means that it will go farther in that volumetric material. So you use less to fill up the same mold you would with chromite sand. Next, I'm going to get into some other material properties, mainly sieve distribution and permeabilities and stuff like that. So as you can see, I've got chromite and silica, both 50 and 55 GFN, and then I've compared to our different product lines, our LD45, ID50, ID70, HT50, and HT70. One thing I want to point out is when you look at this is, since we are an engineered material, we can control the sieve distribution. So we have typically 3 screens sieve distribution, which allows us to have a higher permeability, that coupled with the roundness of our products. When you compare it to a chromite or a silica sand, they have 4+ sieve distributions because it's a mined material, and they can't really get down to that tight of a distribution in a typical fashion. So when you look at that, you take, if you're running a 55 GFN silica sand, which that's kind of a standard for most shops, the permeability is at 63. So if you compare it to like our other 50 grade ceramic materials, like our ID50, it has 222 permeability. So it's over 3 times the permeability of silica sand. So that means you have like virtually no gas defects. You have such a high permeability. The HT50 again is almost 3 times. So the other way to look at this is, if you got 63 permeability on the silica sand you're using, you can actually step down to a smaller size ceramic material like the ID70, as we talked about in part 1, and still have a permeability that's at or above your silica sand. In this case, we're above by over 20 points on both the HT and the ID70. So that means you can step down to that smaller size, get an improved surface finish out of your casting media, and that's one of the big ways how we've seen people eliminate mold wash is you get to a smaller aggregate, which means you don't need the mold wash to get to the finer surface finish. Next, I'm going to talk about a chemistry breakdown of the AccuCast products. The one big thing I want to point out here is silica. You see here that these products all contain silica, and the immediate response is, well, it's still got some kind of a Pell problem there. The answer is no, they don't. This silica that's here is actually chemically bound into the system. So it's bound in with your alumina and, these other constituents in the system, and is in no way a crystalline silica. And I want to mention also, speaking of silica, when you're looking at it, that you need to understand what phase of silica is there. So when you're looking at your other materials that are in your casting process, your resins, such as like a TEOS resin that, creates silica during the reaction, it doesn't create a crystalline silica, it creates an amorphous silica. And the best way to understand what kind of silica is being created out of those different constituents, such as your resins or your mold washes or whatnot, is to talk to the suppliers themselves. They are the experts, and they can disclose to you or inform you of if it forms a crystalline silica or if it creates an amorphous silica or something that's not considered in the OSHA Pell. So it's very important you do that when you're looking at these systems. Testing required for OSHA Pell. So what we want to do now is, as I mentioned, we're going to walk through the AFS study done to understand how much it costs you to maintain a silica system under the new Pell requirements. So first, where I'm going to start with is the actual Pell exposure testing. So Pell exposure testing is where you put an apparatus on the individual and they do their job. And it's mainly to look at, in an 8-hour shift, how much silica dust do they get in contact with. And I should clarify that by saying how much crystalline silica dust they get in contact with. So the costs associated with doing that test are laid out here by AFS's economic study. So the industrial hygienist time and travel, they say, is about $1,600, and that's paid per day at the shop. Also, I want to mention at this time that that $1,600 covers only 1 day, and they can only do 8 job tests per day. So if you have more than 8 job tests, you have to pay for an additional day. And that will be discussed when we get to this large foundry here. Lab fees are $600 per job. So the total per test is $2,200. And the other thing I want to mention is you actually have to do this 4 times a year if you're above the action level of the PEL. So the action level is 25 micrograms per meter cubed. The PEL limit itself is 50 micrograms per meter cubed. So that means if you're above that 25 micrograms per meter cubed, you have to do this test now 4 times a year. So that, including that in this cost, it's $733 per month. I've broken it down to months because in the ROI calculator, that's how we're going to put it in. So I want to show it by a monthly expense. For a large foundry, you start out much the same way. You have an industrial hygienist, but since we're saying you're going to have 16 jobs tested, you need to pay for a second day. To pay for a second day brings you up to $3,200 for the total expense for the industrial hygienist time and travel. The next thing you need to pay for is lab fees. Well, lab fees are greater at $1,600 when you have this many tests. So, again, we go into this. Your total per test is $4,800, and your total per year with doing it 4 times a year, because you're talking about being above the action level, is $19,000, or a total monthly expense of $1,600. Now we're going to get into health screening. So health screening needs to be done right now, or needs to be offered to the employee if you're above the PEL limit of 50 micrograms per meter cubed. As of June of 2020, the requirement is going to change to where if you're above the action level of 25 micrograms per meter cubed. So in that case, what is all involved in this? Well, you got to do the physical exam, which is $800, per exam. Then you have to pay the employee for their time away from work still, even though they're on the test. So they're figuring that's 2 hours away from work. And then you have the drive time you have to pay them for. So they've just said that they figure that to be at least 1 hour. So a total cost per employee is $920. Now we get this down into small versus large foundry. They said for a small foundry, they're thinking probably about 10 people would be a good number to use to say that that's a small foundry. So the total yearly cost is $9,200, and the total monthly cost is $766. A large foundry, they're saying somewhere around 30 employees need to be tested. That brings you to $27,600 per month, and the monthly cost of $2,300. The next thing we're going to get into is a respirator program. So if you have anybody that's working in an area that is above the OSHA PEL limit, you have to have them on a respirator. If they are above the action limit, you could have as part of your action plan to put them on a respirator. That's totally up to you. So with those 2 comments in mind, this is what AFS feels is going to happen at these different small and large foundries. The total cost per employee to put them in a respirator is $1,100. For a small foundry, again, they're going to use a number of 10 people that they feel will be put on a respirator. So a yearly charge of $11,000, or a monthly expense of $916. For a large foundry, they're saying, again, around 30 people, or equates to $2,750 per month. The other thing you got to do with a respirator is you got to have a record-keeping process in place to take care of it, and training. So what AFS did is they looked at it and said, probably 1 week a year is enough time to handle both the record-keeping and the training. But that takes 2 people. One is a manager to properly oversee everything, and you got to have somebody clerical doing the record keeping. So basically, we've broken those 2 down, and we say in a yearly expense of $4,800 to have them keep those records. Total monthly cost of $400. Now, the reason why I only show this once is whether you're small or large, no matter how many employees you have, you're going to have to pay these people, and they're probably going to have about the same amount of time, and is what AFS felt. So now we get into cleaning costs. You have silica in the shop. You've got to clean up according to the new OSHA PEL. You cannot. There's certain things that you have to do differently when you do that. So one is you can't use compressed air anymore. You can't blow around this material because it's deemed to get up in the air and cause you to have more harm according to OSHA. And you're not allowed to use a broom really anymore. So you have to use a vacuum. And that costs money to rent these different vacuums or equipment that you need, or to purchase it. AFS took a stance of you're just going to be renting the equipment, and so this is the cost I feel associated with it. So first off, you have the equipment rental cost here, then you have the employee time cost. So they feel that, this is going to how much time the employee is going to put into doing this, and you have the lost production costs of both the employee not being able to do, taking away from his job and losing of the parts that he could have been making. So that altogether for a small foundry equates to $47,000 roughly, a total monthly cost of $3,917. For a large foundry looking at those same three things, they're seeing a total yearly cost of around $231,000 or $19,000 a month. The last thing that they looked at with this is doing engineering or equipment upgrades. So dust collection or other engineering controls that you would need to put in place to properly mitigate the silica dust. So OSHA broke it down by alloy type. So as you can see, in iron foundry, they believe there would be right around $2.4 million in engineering and equipment upgrades to meet the new standard. Non-ferrous, they say right under $1 million. Other ferrous, they feel will be about $1.7 million. For the sake of this, looking at this ROI, I'm going to just say, $1 million, because, looking at these, that seems like a safe number to use to say that, hey, if you're going to use, go engineering and dust collection and other things, that's probably somewhere safe. So you are looking at spending somewhere around that kind of dollar figure. So now we're going to go into the ROI calculations. And what I'm going to do is I'm actually going to jump over to the Excel sheet I have for the same one. And this is a large no-bake shop we have in here. And kind of walk through these numbers. And also I can play with it some and show you how this calculator works. So first of all, I have CARBO in there at $1,000 a ton and Silica in there at $100 a ton. These are budgetary numbers. These are not 100% correct, but they are, getting you in the ballpark of what each are going to cost. And I know you guys are probably saying I don't pay $100 a ton for silica. We will adjust that number here in a moment. You'll see how that affects everything. I'm saying for a large facility, I'm just using the number of 1,000 tons. I think that's a good number to say, hey, that's definitely a large facility in my opinion. So 1,000 tons at $1,000 a ton is $1 million. I'm also have built in here $500,000 for reclamation equipment. Now, I can't say everyone's going to have to buy reclamation equipment. It all depends on your shop, your usage. So if you're saying the metal ratio is right, you don't need thermal. And most likely in a no-bake shop, you already have mechanical, so you would not need reclamation equipment. Also, depending on your mechanical reclamation, you might not need thermal because it might be aggressive enough where you don't need to do it. There's lots of things that we can get into there to say, do you need reclamation equipment or not? So while I have it in here, it's more just as a placeholder to say, you could end up spending money on reclamation equipment, so I want to have something in here for that. Going down to the other costs. So you've got your monthly costs on the materials themselves, and where am I getting these numbers from? Up here. So one of the huge benefits of going with a ceramic media is that the attrition rate is so low, which basically what we've seen with all our clients is that they do 5% attrition annually. So in a 1,000-ton system, you're only going to go through 5% of that you're going to have to replace from attrition only. Why is that? Because the ceramic material is so much harder than silica and just doesn't wear out, where silica fractures and basically gets smaller, goes up through your dust collection and everything else, so you go through a lot more material. So that's where these numbers are coming from here. Your mold wash, I have in here a very conservative number. I'm saying a 70% reduction. We have people that have completely eliminated mold wash. So this is, a very good number to use for this calculation. And all of these numbers here, we're talking about production numbers. These are taken from estimates of AFS members that have converted their shop. So they're not 100% accurate for everybody. And, what I would say is they're not going to be 100% accurate for your shop. It's where we would need to look over these numbers and run some trials to get what we think is really true. We have a lot of people that they've put in their numbers based on what we've talked about, and after they've done the conversion, they said the numbers are even better than what they thought. So their payoff has been even sooner than what this originally projected. Resin. As I mentioned in part one, we've seen people reduce their resin by up to 30%. I have in this calculation right now a 25% reduction because I don't want to say that you're all going to achieve that, because, again, it depends on your process, how you're set up, what you're doing, as to how much of a reduction in resin you can get to. Cleaning labor. So that involves your cleaning room. We have seen with the improved surface finish and the reduced defects and everything, there is a cleaning room savings, and everybody has seen that. Now, right now, the numbers I have in there for this are very conservative. We've seen much more highly improved numbers than what I have in here. But again, I don't want to put too high numbers in there, just because I'd always rather be on the side of caution. Disposal cost is just what are you paying to dispose of it if you're taking it to a landfill. Again, I have something in there for CARBO, even though I don't necessarily believe you're going to take anything, but out of your dust collection, you're still going to be taking something to the landfill. Sand additives, so that's like your iron oxides and other things that you're using to prevent veining or some other defects. I have 0 in here for CARBO, and just because in 99% of the cases, you don't need any of them. There is a slight chance you might, and that's, again, where we would look at this and make an adjustment. After that, we have all of those OSHA, Pell, maintaining a silica system numbers that we just went over for testing and health screening and all that. I have nothing down for CARBO because if you switch to a ceramic media, you don't need to do any of that. That's one of the huge benefits of switching. You take away that liability. Okay, so as this thing sits right now, year one, it's saying that you're going to pay off this $1.5 million investment between the ceramic media and the equipment, and you're actually going to make $176,000 in this example. So I've created this chart to kind of better showcase this for these examples so you can watch it. Basically, this is saying at the end of year 5, as you see here, you're gonna make almost, or get paid back almost $7 million on top of this conversion by following these parameters. And you can see each year you're going to make about 1.6 million from doing this. So now let's go through and make some adjustments. So you say I'm not paying $100 for silica sand. Well, what if you're paying, what are you paying, 50? Even at $50 per ton for silica sand in this model, you're still coming out ahead at the end of the year. You have still paid off the project, and you are making money of $26,000. If you're asking where does this break even point, it's somewhere around $40 per ton. You can see right there we're at $3,000 that you're still a little bit behind, but you will make that up, in year 2 easily. So next thing is, what if you want to elect people or that you don't need any reclamation equipment? What does that do to this? Well, now obviously you have $500,000 you don't have to pay off, which means your payoff period has went down drastically. And even at $40 per ton for silica, you're still at making almost $500,000 on this conversion. What if we say, let's look at this dust collection if you want to stay with silica, or let's do a direct comparison on the two. So you're going to do $1 million worth of dust collection. Well, obviously it's going to look much, much better because you just put $1 million towards silica to maintain this system that you do not have to put in for the CARBO or the ceramic media project. So, you have all these things, and what if you go up with your silica price? Of course, it gets worse. So, there's a lot of ways we can play with this and show, how it works, and it's all very interesting to see how these numbers play out. People that tell me that it's too expensive, I like to say, hey, we need to look at this and go over it because, I don't think you understand everything that's going on here. Now I'm going to switch back over to the presentation and we'll walk through some other examples. So this again was a large no-bake. We just walked through all the different examples and showed you how the chart works. So we get to a small no-bake. Well, I consider it to be a small no-bake because I just put in a 100-ton conversion. So $100,000 worth of material, and we have reclamation equipment in there of roughly, again, $250,000 number in there for that. What we see here is that you're showing at the end of the first year you have a slight loss at $16,000. But basically, with the way these numbers are working out, instead of it being a 12-month payoff, you're going to be at a 13-month payoff. So you're going to pay it off in the very beginning of the second year of running this. And again, this does not include the $1 million dust collection equipment for silica if you were going to stay with it. Getting into a large green sand shop. again, I have $500,000 in there for reclamation equipment, which you may or may not need depending on your setup. If you don't run any cores and you're all mechanical and you already have a mechanical system in there, you don't need any reclamation equipment. So again, it's all how are you set up now? What are you looking at? Whether you need to spend this. Again, I don't have any money in there for the silica dust collection. Based on this model as it sits right now, what we're seeing is you would, at the end of the year, still be $166,000 behind. But at the rate you were making up your savings each month, it would probably be like a 14 months return on your payoff. And again, as I mentioned already, these numbers are estimates based on what we've seen from people. We have people that have shown a lot better than these numbers. And so, there's people have converted green sand shops that are showing, that their rate of return is, around 8 months or better. So this is just for you to see right now. A small green sand shop, again, 100-ton system. I have $250,000 in there for reclamation equipment, nothing in there for dust collection. You're seeing at the end of year one, you're still about $41,000 behind your investment. Again, this would be about probably 14 months you'd have a payoff, or 13 months based on these numbers down here. So again, you're talking just over a year you would have paid off the project and you would be then making money off of the project. And you can see by these numbers, after 5 years, you would have made $1 million on doing this conversion, or saved $1 million, I should say. A large loss foam plant. Again, we're looking at 1,000-ton plus system is kind of what I'm using as a large system. $500,000 in there for reclamation. You may or may not need it. Again, loss foam, the only thing you would need is maybe thermal. And if you already have one in place for your silica system, then guess what? You don't need to spend that money. I don't have anything in there for a dust collection system. And we're seeing a payoff of, within a year. We're seeing a $43,000 positive at the end of year one with this. The other thing I want to mention with loss foam is we've got a lot of data that shows that you do see a increase in production. So while I can't show the reduction in scrap and that number, because it's varied by customer to customer, how I've broken that down is I've said if you are operating a certain amount of workforce to make the same amount of products with silica as you are with CARBO, is you're going to see a reduction in your labor fees because you're not going to have to work them as many hours to achieve that same number. So that's built into this as well. Small loss foam, again, you're talking about 100 tons to convert, and you're seeing that, and I have a $250,000 for reclamation with all the same type of stuff we've used in the other ones. You're seeing a payoff of less than a year again. So that's all I have right now. I'll open up for questions and hope you all enjoyed the presentation.
Okay, well, thanks, Ray, and thanks, everybody, for your attention. At CARBO, we provide technical support for all of our products, including metal casting. So now for a few questions. Jamie's put these together for us. Thank you, Jamie. Let's see here. Ray, first question here. You mentioned these numbers are from an AFS study. What AFS study are they from?
That's a good question. AFS a few years ago started working on an economic study to show how much it would cost foundries to deal with this new OSHA Pell number. So when they adjusted it down to a Pell limit of 50, they put together this economic study and published it. I have talked to them and went over these numbers to make sure that I am in line with what their publication said.
Okay, well, great. Thanks, Ray. We have time for one more. So let me see here. Here's another question for you, Ray. How can I get a copy of that ROI calculator?
That's a very good question. Basically, as far as the ROI calculator goes, I really like to go in and visit the shop of whoever's interested in looking at it, and that way I can look over and see how we can help you the best and give you some examples of what we see in other people. And then we fill out the ROI calculator with you in person. And so we both kind of see what you're seeing, and I can address any questions you have. And then I usually will leave it with you at that point so you can play around with it more on your own afterwards.
Okay, well, great. Thanks, Ray. Well, that's all the time that we have. If you did submit a question, we didn't get to it, we will answer you directly. This webinar was recorded, so you can play it back at your convenience, so you can look at some of these slides in more detail. Additional information about metal casting as well as other CARBO technologies are available on our website, but please feel free to contact us directly. Thanks again for your attention, and goodbye.